Hello everyone and welcome back to the Cyber Rangers YouTube channel. In this video we're going to be continuing off from where we left off from in the previous video, where we got an understanding, or were able to get an understanding as to how C2 frameworks work. So in essence, in this video we're just building on top of what we covered in the previous video by now getting a practical example as to what a C2 framework looks like in terms of its functionality. So you may be asking yourself, well, what is the C2 framework we're going to take a look at? Well, as the title suggests, it's going to be PowerShell Empire, arguably one of the most popular C2 frameworks out there. And of course, as you probably already know, it is free and open source, which means using it is a breeze. Now, for the practical demonstration in this video, we're going to be leveraging one of Cyber Ranger's practical labs. If you want to gain access to this lab, you can do so by clicking the link in the description section. That'll take you to the Cyber Rangers app, where you'll be able to subscribe to the lab or get a subscription that'll provide you with access to the lab, and you can then follow along. However, if you're watching this just for educational purposes, it'll work just as well, because I'll really be focusing on the functionality of the C2 framework rather than the exploitation of an environment. With that being said, I'm really excited to get started, and let me switch over. So introduction to PowerShell Empire and Starkiller. So there's a few things that I need to clarify regarding Empire. Trust me, it also confused me. It's confused me a lot of times. So technically speaking, the latest version of Empire, which is what we're using, or what we're going to be using, is called Empire 4. PowerShell Empire refers to the original project that is no longer maintained. However, the company that now develops it and actively maintains it, forked from that original project and now calls it, and has their own naming schema with their release versioning system, which is why you can now see it's called Empire 4. There's also Empire 3. And if you want to learn more about this change, or the sort of the transition from both projects, or what the motivations are, because PowerShell Empire, the original project, which is now archived on GitHub, which means it's no longer supported and maintained, still works. Trust me, I've actually tried it out. It still works. But the new version is where, it's actively being maintained, actively being fixed. New modules are being added, based on what the community is actually submitting. So I just wanted to clarify that first distinction. And the easiest way you can sort of separate the two is through their logos. So the original PowerShell Empire project has a different logo, and the new version that's managed or maintained by Cybersecurity is this one right here. Now, one thing that I would also like to point out is that this new release of Empire, or this, I'll just call it Empire now, Empire is now officially being supported and maintained. When I say maintained, I mean they actively maintain the packages within their repos, so that you now have the latest release, which is awesome. That's something that was very hard for them to do, especially with the original project. And you can take a look at their blog post about this. What Cybersecurity has also done is developed a GUI interface for Empire called Starkiller, which is why we're covering them together. And it's sort of an add-on to the existing CLI or Empire client. And the final thing I'll say here is regarding the changes, because you may be wondering what has changed. The only thing that's changed, fundamentally speaking, is improvements to the core of the Empire C2 server code base. Improvements have been made with regards to support for better support for listeners, and also newer modules have been imported and are constantly being added, specifically PowerShell, right? So let's get started with the introduction now that you have a bit of clarity regarding this. Empire 4, I still call it PowerShell Empire. I'm sorry, that's just a bad habit at this point. But Empire 4 is a pure PowerShell post-exploitation framework that's built on cryptologically secure communications and has a flexible architecture. Empire implements the ability to run PowerShell agents without needing PowerShell.exe, rapidly deployable post-exploitation modules ranging from keyloggers to mimikatz, and adaptable communications to evade network detection. So stuff like jitter and a sleep timer, as well as others. All of this is wrapped up in a usability-focused framework, which it is. Empire is really intuitive. It's in fact the most intuitive C2 framework, in my opinion, that you can use. The reason for that, especially in the context of the CLI client, is because it's built sort of very similar to the way the Metasploit framework console is built, with regards to modularity, support for auto-completion, and a certain level of polish, I would say, at least in my opinion. And obviously, you can take it. You can take this away from Empire, but its support for PowerShell modules and modules like mimikatz and in-memory execution of mimikatz is, at least in my opinion, is really, really cool to have, because you can do this with other C2 frameworks, like, we'll be taking a look at Covenant and Havoc today. This can still be done, but you need to import the script or execute it, although they do support, especially in the case of Havoc, inline or in-memory execution. So with regards to its platform support for its implants or its stages, if you will, Empire 4 includes pure PowerShell Windows agents, Python 3 and newer releases of Python 3, Linux and OS X agents, and C# agents. So you can dynamically compile your C# executables, or compile C# into a workable portable executable. And of course, I mentioned this, it is the merger of the previous PowerShell Empire and Python Empire projects. So PowerShell Empire was recently, when I say recently, I think 2020, it recently received an update and is now officially supported and maintained by Kali Linux, with regards to keeping you up to date with the latest releases being produced by BC Security. And if you want to learn more about this, Kali had actually done a great blog post on this, or offensive security for that matter. And in order to get an understanding of how Empire works and the components that make up the framework in depth, it is highly recommended. Please do this, especially after today's session. Just go through their wiki. It's really well laid out and very simple to understand. As I said, Empire is extremely intuitive. So I've already covered or given you that introduction here. Now, with regards to its features, these are some of the key features that it has. Of course, not all of them are going to be important to you based on your requirements, but you have the server client architecture for multiplayer support. That means, it supports multiple users, or multiple red team operators can patch into the C2 server, either through Starkiller, which is the GUI client, or the CLI client. So you can actually configure the clients to authenticate to a C2 server that's somewhere on the internet, either via domain or whatever. It has fully encrypted communications, or the functionality to have that. It has HTTP, HTTPS, malleable HTTP, OneDrive, Dropbox, and PHP listeners. OneDrive and Dropbox specifically for exfiltration of data. And it has a massive library of 400 plus supported tools, and in this case modules in PowerShell, C# and Python. It has a donut integration for a dynamic shellcode generation, and a modular plugin interface for custom server features. This is where I really like it, because if you've used Metasploit for a long time, using Empire is just a breeze. It has a flexible module interface for adding new tools. So if you want to create your own module, you can do that and import it. Very easy to do. It has integrated obfuscation functionality for Confuser X2 and Invoke Obfuscation, which is a really cool script on GitHub for PowerShell obfuscation. You should definitely check it out individually. In addition to that, I believe I have uploaded to the OneDrive folder a PDF or a guide on how to obtain initial access by creating a malicious document and encoding or obfuscating it with Invoke Obfuscation. I'll probably upload it shortly, but if it's not there already. You have in-memory .NET assembly execution, customizable bypasses for PowerShell specifically. You also have a MITRE ATT&CK integration, which is fantastic. Integrated Roslyn compiler, which was taken from Covenant recently. And Docker, Kali, Ubuntu, and Debian install support. So yeah, really feature rich. With regards to its modules, and I'm referring to the key ones here, you have assembly execution, BOF execution, Mimikatz, seatbelt, Rubius, Sharpsploit certified, process injection, which is fantastic, and many more. And with regards to agents, you have PowerShell support, Python, C#, and IronPython. And we'll be talking about the different types of stages you can set up. So just talking about a little bit about the architecture, so so this is clear. Empire 4 introduces a new server and client architecture, which requires running each in separate terminals. So that's one of the massive changes that BC Security made, sort of segregating the core, the actual server, and the client functionality, and having everything modularized at that level. So the PowerShell Empire server is used to manage server-related functionality, and the client is used to interact with the Empire server. The two primary interfaces for interaction with Empire are the Empire client and Starkiller. And some key terminology that you need to be aware of are the listener. So again, we went through this yesterday, but in the context of Empire, the listener is a local process that's listening for a connection or a beacon from a compromised host. The stager is a piece of code that uploads the agent, or gives you the agent, and I'll explain the distinction. The agent is the process running on the compromised host responsible for connecting to the listener, and the module in this case is a piece of code executed via the agent to achieve a specific goal. We have various listeners here. We have a Dropbox listener, which requires a token in order to interact with the Dropbox API. One thing I would like to point out, the Dropbox listener and the OneDrive listener are specifically for data exfiltration. As of right now, I tested the Dropbox listener for exfil last week. That one worked, but I was having issues with the OneDrive listener. So just to give you a bit of a context there, you have your standard HTTP listener, which supports HTTP or HTTPS. You have your HTTP COM listener, which is used essentially. You can use it when you're specifically targeting Windows systems because it utilizes the hidden Internet Explorer COM object, which again really is needed now because there's sort of a similar type of a similar sort of setup can be utilized through your own web server, just through an HTA file. So for those of you that attended the Windows Red Teaming Bootcamp, you saw that in action, which we can also do. You then have the HTTP foreign listener, which is used to inject Empire payloads. The HTTP hop listener, which utilizes the Alin IAAL utility on essentially allowing you to gain control over the target host through an Exchange server. You then have the, sorry, did I cover the actual HTTP hop? Yeah, that's the one that I wanted to cover. So sorry about that. So that one is used to act as a hop server, but fundamentally speaking, works very closely to a redirector. However, in this case, the redirect listener essentially just redirects you from one agent to another, or in this case, from one particular redirector to another if you have multiple redirectors. But in this case, you can just have one. We'll be taking a look at that example. So sort of using a redirector to redirect communication from the agent to the actual C2 server. And for the stager types, you have your bash stager, which is a standard bash script. You have your launcher stager type, which is a one-liner written in a specific scripting language like VBS, batch, also HTA. You then have your macro, the ability to generate macro stages. So you can actually use this, then obfuscate it based on your own requirements, and then include it in a document. Very useful for resource dev. You then have PyInstaller. So this usually gives you an ELF compiled with PyInstaller or even executables. I believe that works as well. You then have jar for jar payloads and application files. I've not covered all of them here, but you have shellcode. That's for Windows shellcode execution that you can customize that to do anything. C# executable. So PowerShell C# portable executable. That's what it'll essentially provide you with. You can. This is what I utilize. I'll typically utilize either a launcher, the macro sometimes, the C# executable, and then I'll dynamically inject that into a portable executable later on. You then have DLLs for DLL side loading. This is very useful for now the post-exploitation side. So let's say you gained initial access via, let's say you utilize something, just as an example, like Metasploit for initial access, and you now want to bring in PowerShell Empire during the post-exploitation phase. DLL side loading is really helpful. Of course, you can also dynamically inject shellcode, or dynamically generate and inject shellcode into a process that you already have access to, and that should provide you with an agent. And then you have your HTA, which is applicable really for Internet Explorer alone, but you can still execute it with mshta.exe. Now, finally, just to take you through Starkiller. Starkiller is, as I said, the GUI that has been designed by BC Security, or developed, designed, and maintained by BC Security. And it's a really fantastic companion. Great UI, although I don't like some aspects of it. And the fact that it is an Electron application means there are going to be some, graphical glitches, stuff like that. But overall, I really like Starkiller. It provides you with an interactive agent shell, malleable profile management. Remember, I spoke about that. The ability to enable or disable modules, a process browser, file browser, and a chat widget for collaborative ops. So if you have multiple red team operators or adversaries all connecting or patching into the Empire server, then you can actually interact with them, because they have their own, you have support, multiplayer support, as I mentioned. So they all have their own accounts, and you can actually chat with your comrades, if you will. But yeah, just to cover the example we'll be taking a look at, I mentioned this yesterday. The first thing I'm going to be doing is showing you how to, get it set up, and I'll walk you through the syntax and the commands. And then we'll take a look at setting up a simple HTTP listener, generating a stager, executing it. So we'll be using it for initial access in this case, but that's really not the focus here. So executing it, getting back the agent, or having the agent call back, and then interacting with it. We'll talk about PrivEsc, situational awareness, and also exfiltration to a certain extent. And then we'll take a look at the second example, where we will be setting up a redirector to redirect the communication from the agent to our C2 server. So this will all be done within the lab. All right, good. So this is the Empire lab or scenario. Do take note under the overview, there's a walkthrough that I did based on what I was going to cover in this bootcamp. Take note of the credentials here for each of the systems, because we will need access to all of them. And as I said, the credentials are also linked here once you click on services. So let's open up the Kali box. Yep, there we are. So that should work, no problem here. And what I'll do is I'll go into full screen. All right, if that's good, then I think we can get started. So the first thing that I want to highlight is the process of getting PowerShell Empire and Starkiller installed. It's very, very simple on Kali. So the first thing you need to do is, just make sure you update your packages. On this Kali box, it's already done for you. So update your packages, and then, you can go ahead and install it. So apt-get, if I can actually type that in correctly here, apt-get install PowerShell Empire. So it's still referred to as PowerShell Empire in the Kali repos, and Starkiller. And you can just install them, and they'll get all the dependencies all installed for you, providing the fact that you are running a modern release or one of the latest releases of Kali. So anything from 2021 onwards, you shouldn't have an issue with the dependencies. So the first thing that you need to do, based on what I covered in the slides, is that you need to understand that the server is started separately from the client. So that distinction is key here. So to execute the PowerShell Empire server, you just say sudo PowerShell Empire server, and we'll let that open up or start up. So it's going to load all of the modules, if you will. So bypasses, stages, modules, listeners, the malleable profiles. And it's then going to expose the API on 1337 specifically for the client interaction. This can be modified. Then going to start up the Empire compiler, and we'll just wait for this to start up. So the C# server is started successfully. And there we are. So this is the Empire team server, as it's referred to as here. You can see at the bottom, you have a status bar highlighting the number of agents connected, the number of listeners currently running, and the plugins loaded. The next thing we'll do is you can now start up the actual PowerShell Empire client. So I'll just open this up here. Again, make sure to run it with sudo privileges. So sudo, or run it as root, sorry. Sudo PowerShell Empire client. And give it a few seconds, and it's going to connect to the server. So there we are. This client is configured to connect on localhost to that particular port 1337, so the RESTful API endpoint. And this is where a typical operator or adversary, this is what they would utilize to interact with the team server. So even though it's running on the same system, it can also be operating remotely. Of course, if you're doing that, I highly recommend you enable encryption. Okay, so first things first, as I said, this is the console. You can see it operates very similar to the Metasploit framework console here. And if I just display the help menu, which is always recommended, in this case, it's not formatted correctly, but I'll sort of explain it to you here. It essentially has a table, and it gives you various commands that you can run based on what you're trying to do. So I'll give you some practical examples that will sort of set the stage, and we'll be able to get started with our first deployment case. So to begin with, I'm just trying to think of where to start. Let's start off with the listeners, right? So if I just type in the listeners command, you can see we have 0 listeners. Listeners are sorted by their ID, their unique identifier, their name. You can set or provide a listener with a name. You have the module, the listener category, when it was created, and whether it's currently active or enabled. You can also check the agents. At the moment, we have 0 agents. Again, this table is sorted based on the following parameters or fields. You have the ID, name, language, internal IP, the username, process, the process ID from which the agent is operating or running, the delay or your sleep timer in this case, when it was last seen, and the listener. So if we wanted to use a listener or set up a listener, we can use the command use listener. And let's set up a simple HTTP listener here. Okay, now whenever you utilize a listener module or whenever you're generating a stager, you'll be provided with a table of configuration. So think of this as the options menu in Metasploit for a particular module, right? So you can see at the top here, you have the information about this particular listener. So who created it, what it does. So it starts an HTTP or an HTTPS listener, PowerShell or Python, that utilizes a get or post approach. So keep that in mind, get or post. Post is never a good thing in most cases. And then, of course, you have the name here. First things first is the bind IP. That really doesn't need to be changed in this particular case. And if you are setting up HTTPS, then you need to provide a path to the actual certificate. The cookie, this is very important because that's going to be included in the request. So you can specify a custom cookie name to make it look more legitimate if the egress traffic is being analyzed when GET requests are being made or when there's a callback. The default delay is your sleep timer. So this is your agent delay or reach back interval. The default is set to 5 seconds. We'll play around with this just to show you the difference here, and we'll try and analyze it in Wireshark. You then have the jitter. So in this particular case, that is 0.0 to 1. So essentially, the way to think of this is in a percentage way. So if I say 0.50, that means 50% jitter, which will consequently give you that amount of variability or randomness with regards to the callback and communication, which is quite important from an egress traffic perspective. And then you have the default lost limit. So the number of missed check-ins before exiting, the headers, which again, take note of this because this can be customized. So it's almost never common to see the server header point towards the fact that someone is interacting with the Microsoft IaaS web server. Although, again, I'm not judging anyone who's running a Windows server to host a web app because that's what we're going to be trying to emulate. The host is set correctly to the IP address of the Kali Linux system. So you can actually see the corresponding IPs. These are all static, so they'll be the same in your lab environment. And then you have the kill date and the launcher. In this case, because it's PowerShell by default, you can also do it with Python, but because it's PowerShell, you can see that In this particular case, it is you can see the arguments provided, the PowerShell execution arguments, which means in this case we can probably modify it because it's not hidden by default, but that's the launcher string, and then the name, which you can change. I recommend doing this, and then the port, arguably as important. So the only option in our case that will be changing is going to be the port, but also take a look at the staging key for initial agent negotiation. That'll come in handy when generating your stager. So in this case, we'll just say set name, we'll say set name, which you can do, and then just provide a name. So we can call this, whatever we want, but in my case, I'm not going to do that. In this case, we want to change the port to port 80. Hit enter. Okay, and you can always display the options just by typing in options to see what the updated changes look like. So in this particular case, you can see the port is now set to 80. All right. Any questions up to this point? Because again, I want to make sure that I'm responding to your questions based on a specific area instead of answering them once I've gone through the entire lab or the entire demo. So feel free, as always. That's why I'm here. If there's no questions, then we can resume. All right, so once you've configured your listener options, in order to set up the listener or to start it up, you just need to type in execute. And that should confirm there we are, listener HTTP successfully started. And now if we list out our listeners, you can actually see that here. So there we are. We can see that it's under the client server category. And it was created on this particular date and time based on what's on the C2 server itself. Okay, the next thing obviously is to generate our stager. So in this case, there's a lot of flexibility here. So in order to do this, you can either go back home, so you can say main, that'll just take you to the home page, or you can just execute it from there. So we can say use stager. So this is essentially your implant, for lack of a better word. So you can generate a macro, bash, let's see some other interesting ones. Ducky, this one is for rubber duckies. If that's your initial access vector, if that's what you want to do. You also have HDA, shellcode. That's also quite useful. Let's see which one we want to use here. I'll just show you a couple of examples first. So the first one obviously is PowerShell, which I think we can use as an example. Or let's see. I'll cover as many as I can, keeping into account that we need to also factor in time. But the one I'll use, you can actually filter by platform. So if you want Windows stages, you just start off with a prefix being Windows. If you want multi-platform support, the same thing here. That's where you typically generate one with Python and then compile it with PyInstaller. So in this case, we're going to use Windows, and let's start off with a launcher to keep things simple. So in this case, we have a Visual Basic, batch script, etc. So let's use this one, and then I'll show you an HTA and how that can be used again if you do intend to use it for initial access. So with regards to the options here, again, the table will be displayed. So you get the info about this particular stages. So generates a self-deleting bat launcher for Empire, only works with the HTTP and HTTP COM listeners. So always take a look at the info being displayed there. For the bypasses, this is specifically referring to bypass techniques, which I'll probably go through once we've covered Starkiller, because they are in reference to Windows specifically. You then have the delete option, which allows you to switch or delete the batch after running it. So in this case, it's set to true. The language is PowerShell. So that's the language of the stager. And then the listener, we need to set it to our listener, which in this case, we know the name is just HTTP. If you want to obfuscate the PowerShell code, you can set that to true. So these are your Boolean options. So it's either true or false. In this particular case, it'll utilize the obfuscate command for obfuscation. And then right over here under the obfuscate command, this is for invoke obfuscation. So in this case, it's only obfuscating the PowerShell tokens. You can also change this to obfuscate like the AST nodes within the PowerShell script. And you can then specify the out file or where you want this saved. In my case, we'll just save it in the default directory, which should be under the var folder. First thing we'll do is we'll set the listener to the one we created, which is HTTP, right over here. And again, once you're ready to go, you just hit execute, and it'll tell you where it's saved. So right now it's saved by default under generated stages and then launcher.bat or batch, if you will. So I'll just copy that there, or the path to that. And now I'm just showing you the initial access first. Of course, I'll show you HTA as well, but I'll just head over to my desktop here. By the way, take note of the user account you're using, and then I'll just sudo copy, and we'll copy it just onto the desktop here. There we are. I'm guessing we'll have to modify the permissions here. So sudo chown, the user range admin, range admin, and the name of the file is just launcher.bat. There we are. All right. So now, if the Windows system in this case does not have AV enabled, but has I believe it has the actual user account control level set to normal or high. I'm not sure, but we'll actually be able to find this information out. So as I said, C2 frameworks are not designed for initial access, but in this case, we need to simulate it somehow. So we know that port 80, we have netstat here, is already being utilized by our listener. Actually, yeah, there we are. So that's being utilized. So we can set up another web server with Python here. So I'll say Python 3, if I can actually type that out, Python 3, and we'll use http.server and run this on port 8080, which is not being used. So we can now transfer it over to the Windows system, which I'll do. And then we'll take a look at some post-exploitation techniques and specifically around situational awareness, credential access, privesc, and also exfiltration, specifically with regards to testing the egress side of things, or the various ports you can essentially exfiltrate from. So I'll open up the Windows system here, and we'll just open this up in Guacamole. That should automatically authenticate for us as the admin user. So in this case, we can just use, in this particular case, this always fails to load for some reason, but we'll just go into this particular case. We can open up PowerShell or command line interface here. We'll just increase the font size so you guys can see this. So we can utilize, something like cert util. The IP of the Kali Linux system, I believe that's 11, and port is 8080, so that needs to be specified explicitly. Name of the file is launcher.bat, and we can save it as launcher.bat. Okay, so we saved that within the actual home directory for this particular user. So, we can just execute it from within. So just switching back here, just want to make sure. So there we are. We can see the GET request here for that file. So we have executed that. We have our listener running, so we can actually just go home, and we'll now wait for the callback once we execute it. Any questions up to this point? Before now, again, this is just one deployment example. I'll still show you the redirected technique. Any questions at all? So here's the launcher. Should execute without an issue. If we go back to Kali, there we are. It sends the agent. So that's the second stage, because this is a staged payload. And you can see that's the Windows IP there, or the IP address of the Windows system. So we've now gone through that really ugly emulation phase of sort of rather simulating what it would look like after we've already obtained initial access. So now if I list out my agents. I'll just zoom out temporarily to show you what that looks like, because this is not being formatted correctly. But you can see you have your listener ID, that's HTTP, and the listener, and then the ID of the actual agent itself. Just let me know if this font size is still visible here. There we are. That's much better. So the language is PowerShell, the internal IP, the username or the host name of the system, the process ID, the delay, which I'll also show you how to modify, and then the listener and when it was last seen. So it should ping back or call back or send a beacon back every 5 seconds based on this current setting. So, if we were to open up Wireshark here, just to show you what that would look like, because again, in this case, you would still see the callbacks anyway. So on the target network side, it would still be the same. The only thing is that would be outgoing traffic. In this case, it would be obviously incoming, at least in our case. So I'll just set this filter to HTTP here. So there we are. The capture is still ongoing. So there we are. You can see after every 5 seconds, communication back and forth. There we are. So this is very suspicious. 5 seconds is for callbacks is a heck of a short amount of time. And of course, this will be making requests. The Windows system will be making requests to the specific URI or path, or the path to the file that you had specified when generating the listener. And I'll be explaining this as we proceed. But any questions thus far? And of course, if we open up these GET requests, well, actually, before we do that, let's try and communicate a little bit. So I'm just going to stop that capture here for a second. And let's go back in here. To interact with an agent, you just say interact and then provide the name. You can also rename a particular agent. So in this case, I can just call it Win10. And now if I display my agents again, there we are. So it's called Win10. So I can now say interact Win10. And now if I open up the help menu, I can run some, I would say, built-in commands that, not really modules per se, but built-in commands similar to Meterpreter, where you can open up a shell on the target system, for example, or execute a command. And in this case, the most important ones, of course, downloading a file, which is not really, I would say, this is not the preferred way of, this is not really the preferred way of file transfer, but I'll get to that. And then you have the history, which is very important in this context, the info for a particular agent, which I'll get to as well. But these are the commands you can run. And you see you have stuff like bypass UAC, steal tokens, inject, using shell inject and spawn, which I'll get to as well. But if I say info in this case, this is very important. So this will give you info about this particular agent. So firstly, its ID, the architecture, when it checked in, the delay, the external IP, which in this case, it only has one network interface card. So if it had both an internal and one that was part of another network, or possibly one that was part of a DMZ or publicly accessible, then it would also highlight that as well. The key thing to take note of here is the high integrity value, which is set to 0, which means it's not you do not have elevated privileges, or this agent does not have elevated privileges. When you do have a high integrity agent, the agent name will typically have an asterisk right beside it or as a suffix, and the high integrity option will be set to 1. The host name, the internal IP, the jitter, which I mentioned, so on and so forth. So what else did I want to highlight here? There we are. So the profile, which I'll talk to you about. So this is where you can sort of customize based on your own requirements. And this will consequently affect how Empire, the actual server, will handle that agent based on the profile you specify. That allows you, just based on the actual profile over HTTP, like if we changed, we created another profile that allowed us to modify. So, we can say change admin to maybe uploads and get.php and sort of modified the profile. And we sort of use that to generate our implants or stages. And that means based on the way we configure the profile, the server would treat it differently. So we'll get to that. That may be a bit confusing at this point. Okay, so that's just the basic functionality around agent interaction. For some reason, my terminal is not clearing out here, but there we are. Okay, so as I was saying, we can execute some native built-in commands. Remember, this is not really a shell session per se yet at the moment. A few interesting ones are, like, for example, we can perform some situational awareness, like who am I, for example. It's going to task that to that particular agent. So because it's over HTTP, you have to give it a couple of seconds. You can always, if it doesn't display the results immediately, you can always open up the history to view the results for a particular task. So it tells us right over here, task 1 results received. This is the host name of the system. And then I can run a command like, ipconfig, and we'll give that a couple of seconds as well. And you, again, just run the history command. And until we get the results for task 2, was that actually tasked successfully? Let's see. So no, it wasn't. In certain cases, we may have a delay. So I didn't get a confirmation that that was tasked successfully. So we'll just give it a few seconds while we're waiting, just so I can confirm this. I'll just type that in again. If you have any questions, feel free to ask, and then we'll talk about some modules here. So feel free. I'm happy to break at this point in time before we take a look at some post-exploitation techniques typically used, or the reason why you would utilize a C2 framework. And actually, I forgot to start up Wireshark because I wanted to highlight something here, or rather forgot to start up the capture. So just give me a moment. In fact, I think I'll go main. It's calling back. We can actually see it in Wireshark. For some reason, we're not getting. So in certain cases, this may be buggy. So it'll say interact with Win10 here. And if I now say history, I should have automatically parsed. Yeah, so ipconfig looks like it's not a command anymore. That was actually my mistake. But yeah, we can open up history. So that was working out just fine. There we are. So we can see the results. So again, at this point now, once you've obtained initial access and you've got your stage executed, you now have access via your C2 framework, in this case, Empire. What do you need to do? Well, the first thing, of course, is to perform some local enumeration or get some situational awareness. Now, if you want to utilize the inbuilt situational awareness modules, you can actually search for them. So you say use module and then situational awareness. So based on what you're trying to look for example, you may want to know what antivirus products are installed and are currently active de facto on the system. You can use this one here. So this is a PowerShell module that's executed in memory. So the agent is already configured to the one that the only one that we have. And in this particular case, whenever you're using the post-exploitation modules, take a look at the info, specifically the parameters with regards to the privileges required. So this is very similar to how MITRE ATT&CK, the MITRE ATT&CK metadata works for specific techniques, sub-techniques, and/or procedures. In this case, it's OPSEC safe. And you can take a look at that particular technique there. So in this case, it doesn't require admin privileges. And they actually have a references there if you want to learn more. Okay, you can then specify the output function to essentially convert it to whatever format you want. In this case, it is out string, which means we'll receive it within our terminal here. So we can just execute this. That'll be executed as a task. So there we are. We want to give that a couple of seconds there. So the job has started for task 3. So there we are, get antivirus check completed. And in this case, the results point towards, sorry about this, the results point towards, it provides the computer name. The antivirus solution in this case is Windows Defender, and the real-time protection status is set to unknown, which means it's disabled. And the product executable is, Win Defender. If it was enabled, it would have pointed towards that. So yeah, basic situational awareness. Let me show you some other ones here that are very useful that I utilize. So again, we'll just say situational awareness, specifically with regards to Windows systems. You can utilize seatbelt, but I'll get back to this shortly. Of course, computer details, but you also want to monitor or to check who else is logged onto the system here, which I believe should be here. You can also run Win enum for more generalized type of local enumeration and also the UAC level. So let's actually run Win enum first, and I'll go through it sequentially, ideally speaking. You can also specify keywords to use in file searches and the username you'd like to enumerate if that is applicable to you. But of course, in this case, does it need admin? No. And is it OPSEC safe? Yes. So okay, let's just check the history on this here. Okay, so there we are. The Win enum is done. So this just does general local enumeration, the stuff that you typically do for situational awareness, like the firewall rules. And there's actually one that I really like, and I'll show you that it does actually work really well. But you have your firewall rules here. Let me just scroll to the other results displayed. Of course, I'd recommend that you output this into a file, not scroll through it like a maniac in the terminal. I don't even think I have a good scroll buffer here. In any case, that will perform, it'll automate most of the stuff you do when you get onto a Windows system. Now, I want to show you a few others here because there's one that is particularly important. One being the monitored the TCP connections, but the one I'm looking for here specifically is the get UAC level, which will be important in this case because the stadio was executed using the admin user. However, we don't know whether it's part of that, so we can say, sorry, let me just take a step back here. We can probably identify that already, but we'll then run the get UAC level. So just to show you what I'm going to do here is I'll say shell oh boy, that's going to load the, I don't know why it's loading them from the latest ones onwards here. Sorry about that. Again, I have to drag this quite well. Wait, actually, hold on, hold the phone. I do apologize for this, passing out this. Okay, so this is still part of Win enum. That'll probably be displayed at the highest level. Another option, of course, which I should have done earlier because I was aware this was going to be the case, is just, shell always good to execute the native commands on within a shell. So there we are. You can see the admin user is a part of the local administrators group. So now, ideally speaking, we would be able to utilize this module knowing full well that if the UAC level is lower than medium, then we could possibly bypass UAC to elevate our privileges. That's weird. Task 8. Interesting. Will we have to scroll here? Possibly. But we would have also been able to find that information out as well. Anyway, what I also wanted to highlight, I'm trying to remember, we still have one more deployment example, and for that we'll use Starkiller to do it. That's the use of a redirector. But yeah, there's a few others that I wanted to show you. So firstly, hold the phone. I just want to see whether I've missed anything here with regards to the native ones that it has when interacting with a an agent. I'll possibly be able to show you all of them. Of course, these can be modified. We'll take a look at Wireshark because I know that's been running for a long time. Yeah, this is what I wanted to highlight. So script import. So this will upload a PowerShell script that's not on a module already because they do have good support, and it'll run it in memory. So that's one interesting one. What did I wanted to see if they highlighted here? Yeah, so what I sort of wanted to highlight, and I don't know whether I can give you an example of this, but just give me 1 second. Let me just open up the history. Actually, hold on. Just 1 second. I just wanted to show you one other piece of functionality here. So Sherlock is built in as a module. So this will run the Sherlock module. I can give you a brief as to what Sherlock is if you're not familiar with that. But the built-in commands are, fairly simple. Very similar to Meterpreter. You have the keylogger, which again is fairly easy to use. I think I've highlighted this before, and you also have the ability then to upload. So this will task the specified agent to upload a file, and then download, of course, exfiltration at a very basic level. And then you can obviously modify the sleep. So you can set the sleep to something like a couple of seconds or maybe even a minute, and then adjust the jitter. That'll of course affect the responses that you get. But there we are. You can see we've actually captured a ton of traffic here. So what I wanted to highlight is, let's see, this is the profile here. There we are. Okay. So let me just see this, if I can get it into sequence here. Okay, that's the get again. We have the response. That is working correctly. I'm now going to, there we are. So you have that cookie there. That's what I wanted to highlight firstly. That's going to be based specifically on the profile. And then 1 second here, you can actually see the data being transferred via TCP. So in this particular case, we would need to set the .source to because we are monitoring it from the C2 server itself. We'd set the source as actually that'll not really work that well, but we can just get rid of the filter here to demonstrate what I wanted to highlight. So just give it a few seconds. So 1 moment, let me just see the way I can show you an example here. We'll be able to see the data after the TCP three-way handshake is established. I think we saw an example. Now that was DNS. So there we are. Okay, so I'm just trying to show you the data transfer here. What is that sequence? Yeah, that is. Okay, hold on. That is reassembled. There we are. So those are the segments. So this is how the commands or data is transferred. Now, you can see that by default, as I told you, one of the advantages that you have with stuff like Empire or a C2 framework like Empire. Hold on. That's not pointing towards what the actual target system and the communication between the agent and the actual C2 server. So I want to just show you an example here. That's coming from 11 to 100, which is the gateway. We've actually captured a lot of packets here. Hold on. All right, there we are. So okay, so let's take a look at one that is, there we are. So TCP segment that just points towards, yeah, okay. So let me give you an example. Let's scroll a bit lower here. Any questions thus far? Let's take a look at this reassembled one. Yeah, okay. All right, so the point I was trying to make in any case is, obviously, if you're deploying this for a real operation, red team op, or whatever you're trying to accomplish, it's important to keep in mind that because of the nature of the listener that we've set up and the communication channel we've established, people are going to be able to intercept what is being sent and read it in almost clear text, as you can see right over there when we in the ASCII view there. So you need to also consider, setting up an SSL cert so that you can set up an HTTPS listener, because that gives you that added advantage. Now, coming back to the actual use case here, the deployment example, we're just going to do a little bit more here. And I think we're still good on time, because this is actually quite important, the concepts that I'm trying to cover here. So if we open up the history here, and that was the, yeah, that was for, what task was that exactly? So what, hold the phone here. So get UAC level. I believe you can. That should display the, sorry about that, the history of the results for that particular task. That's weird. That now is sort of reordering stuff here. All right, so there we are. So you can see that now it's sort of pointing towards that. I'm not sure what's going on with the actual results for the various tasks. In any case, we checked to see what the UAC level was, and in this case, it's set to never notify, which means we have two of the required parameters to elevate our privileges by bypassing UAC. So we can now say use module and then, bypass UAC, so we can elevate our privileges. And we don't use the ones from, these are pretty much pulled the UAC grunt, and these are taken from Covenant. What we want is just a standard bypass UAC module here. And this is going to connect as another agent. So it's going to ask you for the agent to run this module on, which is Win10. You then specify the listener. This is the advantage with C2 frameworks, is a listener can be used to receive communication or establish a communication channel with more than one agent. So you can see in areas where there is obfuscation, and that's an actual feature or an availability, then you'll be provided with that option, as well as the invoke obfuscation commands. And then, yeah, I don't think we need to, for some reason, that's weird. Okay, so we can just execute this. And now, if we switch over to the Windows box, I'm just going to reconnect here because that timed out. That's an RDP thing. We shouldn't have got any dialog box prompt up, and there we are. We can see that the user is not prompted with a UAC consent prompt. So if we now check our agents, again, this is still an agent now, a high integrity agent running on the same system. So you can see it here. You can see the IP is still the same. And now, remember I said that high integrity agents or agents with elevated privileges will have an asterisk highlighted next to it. So from this point on, we can rename it or interact with it. So we can say rename this one to, Win10. Should I have passed that in a string? Rename, hold the phone, Win10. That's weird. So let's rename it here. And that was actually supported previously. We'll just set it to high integrity, just so that we're able to identify them. So there we are. So we can now interact with that one. There we are. And we can now, run some of the native ones like, Mimikatz. This will utilize or run the command, the first one. So that should dump the actual process cache for the LSAS process. So again, let's just wait and see here. All right, so we'll give it a couple of seconds. This also has a module. There's also other implementations of Mimikatz, so I'll just show you that right now. So you have Sharpsploit implementations, and then you have the individual PowerShell implementations where they also executed in memory. So you have logon passwords, the cache. You can also purge. There's silver ticket and also golden ticket modules, and also DC sync for AD privesc. That's a particular vulnerability that's quite useful. And also then, let's see, there we are. LSA dump is also available, which is my personal favorite. So again, take a look at the info here. Needs admin. All right, so there we are. That was from task 1. And let's see if we can find any creds here. We probably the only way we're going to get any creds, we get the hashes, but there's nothing from WDigest or Windows Digest or the Kerberos. Let's see. Yeah, so that's around the secure LSA, logon passwords, and then the jobs for task 2, nothing yet. All right, so that just started, so we'll give that a couple of seconds. And then there's one more aspect that I wanted to cover. And yeah. Right over here. See if that's returned. There we are. So LSA dump. We get the NTLM hashes formatted nicely. And we get the hashes for, admin, etc. If we're working within an AD environment, we could have done some lateral movement tests here. Now, the other one that I wanted to highlight with regards to exfiltration and the nature of egress traffic in this particular case, by the way, let me just stop this here, and we'll revisit that shortly. But what I wanted to highlight was, let's say I've gained access, again, part of situational awareness. One of the things that you wanted to do was sort of identify, if you haven't, performed your local enumeration well, you sort of want to identify what ports you can use for exfiltration. So I'll say use module, and I'll just, sorry, I keep using the tab key here, but I'll just type it in here. Egress, there we are, exfiltration, egress check. That's the module here. So again, this will generate traffic on a provided range of ports and supports both TCP and UDP. It's useful to identify direct egress channels specifically for exfiltration. And this is not OPSEC safe. So again, this is where you start doing your tests here. So in this case, you'd specify, like if you've set up a listener or you've set up a service, for exfiltration or whatever. In this case, you're just using it to test. So the way this would work is you specify a port range. So in this case, you can see port range is 2250 to 2225. SSH, that makes sense. That's used quite a lot for exfiltration. Also FTP to a certain extent. You have SMB, not that common, but what you can do is we set the IP here. I'm going to set the IP to 192.168.125.11. That's the IP of the Kali Linux system. I'm just showing you an example here. So I'll now open up a new terminal here, and let's get rid of our web server. And I'm going to set up a Netcat listener, and we'll set it up on port 23, which is telnet. Again, that's because SSH is currently being utilized, or 22 is currently being utilized. So now let's see whether we can actually use that potentially based on the firewall rules, or whether we're having any issues with egress filtering. So this is what's very useful for testing egress filtering here. So I'll execute it. And now, there we are, we get a connection. So we know that, this is, we can actually utilize that particular port, for a direct egress channel, or as a means for not egress, sorry, exfiltration channel. Sorry, I'm getting a bit confused now. But any questions there before we now take a look at the second deployment model, which is with Starkiller? All right, so that was how to utilize PowerShell Empire for exploitation and post-exploitation. And in the next video, we're going to be, doing a follow-up of what we covered in this video by taking a look at the GUI front end for PowerShell Empire, which is called Starkiller. So I hope you're excited for that. If you want to get notified as to when that video is uploaded, then definitely subscribe. If you found value in this video, please leave a like down below. And more importantly, if you have any comments, questions, or feedback, then definitely leave them in the comment section down below. With that being said, thank you very much for watching this video, and we will be seeing you in the next video.